Hi, so today I will be talking about the probability in statistics. It's one of the important topics, especially if you are later on getting into the topics such as Bayes' term. It's important to you understand the basic concepts. So probability means like probability of calculating event occurring among all possible outcomes. So in statistic, we are writing it as a P of A. It means that probability of event A happening. So with simple words, we say that it's a set of all favorable or potential outcomes. We say outcomes divided total set of outcomes. Total outcomes. So the one of the prominent examples that we give to understand probability is a coin. So when you flip or toss a coin, you have two possible outcomes, and meaning that what we refer as sample space or set of possible outcomes, we can get for one coin, you can either get a head or a tail. So you cannot have both at the same time, as there is no third option. So it means that we're gonna get ones with a head and tail. So which means that the set of possible outcomes or sample space, what we call in statistic, is gonna be 2. But let's say that now we have not one coin, but we have 2 coins. Okay, what's gonna happen with 2 coins? Okay, so for 2 coins, we have 2 possibilities again, heads or tails. Let's say if we get heads during the first flip, the second flip we can get another second possibilities, again head and tails. So likewise, if we get the tails on the first flip, on the second flip we get also again head and tail. So it means that we have 4 possible outcomes. So our sample space is gonna be the first outcome, which is gonna be head and head, so which means HH. Then we get second outcome, head and tails, so it's gonna be HT. Then for the third outcome is tail and heads, which is a TH. And the fourth outcome is gonna be tails and tails, which is gonna be TT. So this is gonna be the sample space of flipping 2 coins. So we have 4 different outcomes. So let's say we have a sample space. Let's have a look what's the sample space of flipping 3 coins. So for this easy and to get the idea of visualization, we can use the tree diagrams. So again, we have a head and tails. So if we get head, we can get head and tails here. So again, the same, we can get head and tail. Since we are flipping 3 coins, so we're gonna repeat the process for each one. Again, we're gonna get head and tail here. So again, the process is repeated and we get head and tail. So when we start constructing our sample space, so what are the results that we are getting here? So we are getting head, head, head. So H, H, H. Then we can get head, 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 tail. So it means H, H, T. So we can get again H, T, H. So H, T, H. Then H, T, T. H, T, T. So if you follow accordingly, then so this is our T is gonna be T, H, H. So T, H, H. Then we get T, H, T. THT, then we are following TTH here, TTH, and the last one's gonna be TT here. So it means TT 3 times tails. So it means that we get in total 8 different outcomes here, okay? Okay, so in our last video, I explained, like in simple words, what's probability, what's a sample space, and there is a help of tree diagram. We have seen what are the possible outcomes or flipping 2 or 3 coins. So in this specific example, we will look at it, how to answer, for example, the question, if 2 fair coins are flipped, what's the probability of getting at least 1 head? So it's an important point is to look at this point at least, because this is gonna change the result outcome. So we are talking about 2 coins. The possible outcomes, of course, when flipping 2 coins, we can get is HH, HT, TH, tail, tail. So there is in total 4 possible outcomes. And then we have to choose the ones that are fulfilling our requirements. So requirement is that we need at least 1 head. So it means that it should have at least 1, or it could be 2 head HH inside. So from here we choose HH, HT, TH. So this is our favorable outcomes. And the last time we said that to find the probability, we have to divide the favorable outcome to the total outcomes possible, which means P is equals 3 divided to 4, which gives us 0.75, and multiplied with 100 we get 75%. So how do we interpret the result? It means that there is a 75% of chance of getting at least 1 head, 1 H, when we flip 2 fair coins. So we move to the second question. Here we have been given 3 coins, and when the 3 coins are flipped, what's the possibility of getting at least 2 tails? So this time we are requested to find the 2 T's. So again, with the help of tree diagram, we see the possible outcomes here. So there is in total 8 possible outcomes that we can get. And our favorable outcomes, which means fulfilling the condition of getting at least 2 tails here, are this one, HTT, THT, TTH, and TTT. So there is in total 4. So 4 divided 8 gives us 0.5. Again, this time it means that there is a 50% of chance of getting 2 tails when the 3 coins are flipped. And we have here the third question, and here we have been requested actually to find, if the 3 coins are flipped, what's the possibility of getting exactly 1 tail. So here we have to have only 1. Here's just important to pay attention, at least or exactly 1 tail. So again, from here we choose the ones that have only 1 T, which gives us HHT, HTH, and THH. So there's only 3 favorable outcomes. Again, P is equals 3 divided to 8 total outcomes that we can get out of it, which gives us 0.375, multiplied with 100 gives us 37.5. It means that there's a 37.5 of chance of getting at least 1 tail when the 3 coins are flipped.